Yeah. So friends and respected senior members of INS, on behalf of INS Webinar Subcommittee, I welcome you all to today's webinar. In the past, we have had a talk by eminent speakers on diverse subjects covering many aspects of nuclear science and engineering and beyond. The objective had been to keep INS members aware of the latest developments in the current science, engineering, and technology that delivers benefits to the industry, public, and overall development of the society. Today, we have with us Dr. Kallol Roy, former CMD Bhavini, and currently guest faculty in IIT Madras, to speak to us on evolving appropriate engineering strategies and sustainable designs in techno-commercial and societal framework and Industry 5.0 perspective. I welcome you, sir, to our INS webinar. So this is a very important subject with multidisciplinary, multidimensional impact to the project's authorities and several takeaways to industry. So INS members may recall the third day of INS annual conference, that is on 30th of March 2022, wherein we had specially invited industry partners who had and have made significant contribution to the department's program. The deliberations brought out several aspirations on either partners because of delays in executing the order or placement of order were particularly discussed. The message was very loud and clear by DAE. That is, DAE is ready with the design and funds. Industry need to mobilize in the mission mode and meet the deadlines and targets. CMD NPCIL too made an appeal to the industry to tailor their approach to meet the stringent requirement of nuclear components. He emphasized it in several times. In today's talk, Dr. Kallol Roy is going to talk more on these, particularly in the context of requiring an upgrade in the Indian industry. I am sure INS members will get to know the evolution of industry from 3.0 to 5.0 era. I will request our President, S.K. Mehta, sir, to make his opening remark and formally welcome the speaker before Dr. Ramanamurthy introduces the speaker to the members.
Well, Kallol, it's again a pleasure for me. Thank you, sir. To invite you, welcome you as the president of INS and in my personal capacity. I recall my very intense and very technically sound interaction with you when you were at bar. And I'm sure that your involvement in the PFBR has brought out many aspects which will be useful to both the designers and industries. I can see the title of the talk has generated out of your experience. I will not dwell on that. I welcome you, and I'm happy to see that you are technically active and keep doing that one, because the Department of Technology has spent 35, 40 years on us to give us the technical inputs, and it is our duty to return it back. And I am sure that you will be doing that one. So I'm happy to interact with you and see that I'm looking forward to your lecture. Welcome to you all. Thank you.
Thank you, sir. Yeah, now it's my pleasure to present the profile of Dr. Kallol Roy. Dr. Kallol Roy is a BTech from NIT Calicut, graduate of the 28th batch of training school at BARC, MTech from CEDT IISc, Bangalore, and PhD from SISCON IIT Bombay. He was also a postdoc fellow at the University of Alberta. Prior to Dr. Roy taking over as CMD of Bhavini in April 2016, he was heading the Research Reactor Maintenance Division at Mumbai, BARC, and he had worked for 3 decades as an instrumentation engineer in the research reactors at BARC. During his service at BARC, Dr. Roy, apart from his primary responsibilities as C&I maintenance engineer of the research reactors of BARC, had been primarily associated with the refurbishing of Cyrus reactor, computerization of Dhruva C&I systems, and commissioning of P4 facility. He had also served in various safety committees of AERB and BARC for carrying out peer reviews on various design aspects of nuclear power plants and other nuclear facilities. Dr. Roy had also served as a faculty of BRC Training School, where he had been teaching courses in instrumentation and control, and he was subsequently a professor of HBNI from 2008 to 2016, and during which period he had guided a large number of MTech and PhD students. As head Bhavini, as the pivot person in Bhavini, apart from his primary responsibilities of project management, he was also closely engaged. He also closely engaged himself with team members from Bhavini, IGCAR, and visiting experts from BARC for carrying out performance assessment of the secondary sodium loops, vibration analysis of large rotodynamic equipment, modal analysis of static equipment, flow fragmentation studies in electromagnetic pumps, and several other such important aspects of the plant. Further, as a part of technology management, Dr. Roy was also working towards application of embedded sensors in concrete structures, Bayesian forecasting and robust control techniques for optimization of system commissioning and project schedules, evolving the concepts for technology forecasting and sustainability engineering, and human reliability and cybernetics aspects. Dr. Roy retired from Bhavani in January 2021 and has since been associated as a research advisor to the Dean Global Engagement and a guest faculty at Chemical Engineering Department, IIT Madras. His present research interests are towards extending the concepts of fault detection and diagnostics for dynamic systems to transitions in complex dynamical systems in the framework of dynamical network controls, distributed estimation and project matrices, etc. As a guest faculty, he has also been offering a major part of the semester course in modern control theory to MS and PhD students pertaining to air pollution monitoring. He is also an advisor to the Office of the Global Engagement, IIT Mumbai, and has been working towards implementation of people capability mature model, SWOT and ERP analysis for professionalizing the office and also studying the options of various game theoretical paradigms for strategy planning. So with this brief introduction, now it's my pleasure and privilege to please welcome Dr. Kallol Roy to come forward and commence his presentation. Dr. Roy, please.
Thank you, Dr. Ramnamurthy, for the very kind introduction. At the outset, I have to pay my respect and homage to all the seniors who are here. I had grown in their shadows for many years in BRC, and I must say that as I speak, I stand on the shoulders of giants who have shaped our organization so well. It has given me immense pleasure for all the experience that I have got and for everything that what I am today. It is this organization of BRC and all the seniors who are there who have helped me grow. Thank you so much to all of you, and my sincere respects to all of you for being where I am. And I thank the organizers for having invited me to this talk. Before I begin, a customary check with Dr. Ramarao sir. My voice is being heard, at least to some level. Sir, you're on mute.
Yeah, we are able to hear you.
Okay. I will give a perspective of essentially the supply chain management issues of small miniaturized components in a nuclear plant, without which nothing really would move. At the same time, they don't come under the scanner or radar of big issues. See, large components, there are engineering systems in the country, engineering companies in the country with, okay, there could be delays, there could be certain issues, but they still tend to deliver. But when it comes to multiple customized, specialized issues, let us say a bearing ball of a particular hardness, let us say a gasket of a particular polymer component with a temperature threshold, let us say vibration sensors, which can take 400 degrees Celsius. Let us say SS gaskets. Like that, there could be multiple small components which are part of the supply chain, and we have a lot of difficulty in getting them. Perhaps one of the primary reasons is unlike the US, where post-World War, all the good students of Berkeley, Stanford, MIT, what have you, have got into small-scale industries and MSMEs, and they've been developing very high-end customized products. The same thing happened in the European market, etc. But unfortunately, perhaps in India, we have always faced the problem of buying a few pieces from somebody. The somebody may be capable, but then he asks us the standard question: how do we sustain financially if you are place your order once in a few years? So these are perpetual questions I know we've been answering, but these are the areas where I think we should keep focusing. One of the perspectives which I would like to give you today is the country is opening up for startups. And as the country grows, these startups very obviously are more towards the commercial domain. Now, can we as a nuclear entity use all our titans in the nuclear industry and all our efforts and knowledge base to push and encourage startups, MSMEs who are customized and specialized services, and to fall in line with our requirements, which apart from the technological challenges, should meet safety challenges, should meet industrial safety issues, and what have you. So perhaps these are some of the areas where all of us have expertise, and so do the society at large and the students coming out have. So there are manufacturing and fabrication strategies, systems and domain knowledges. Of course, we can train people, knowledge of basic math sciences and analytical tools, and all the various niche areas and market gaps, these all can be addressed. I specifically chose this topic because just about a month ago, ISRO chairman and many others had invited a whole lot of college students. My daughter happened to be one of them. That's why I know it firsthand, to just encourage them to make startups. And the whole ISRO body had presented the niche areas and market gaps where these startups could come up. And they had invited investors and others also in the same conference, explaining people what are the pitfalls in startup apart from the benefits and how to override such pitfalls. So perhaps even challenging technologies like ISRO, DRDO would be facing similar problems. And I would expect that even we must move forward and push the boundaries and get the bright students who are into startups to step away from commercial domain and try to come into the nuclear domain or high-end industrial domain. I do agree that we must give a business model which is worth its salt, because unless we give a business model which would have a large package of commercial outputs and there is a profitability in that, nobody would make specialized products which would sell only once in a periodic point of time. Well, having said that, perhaps the basket of our people are quite large. We need to understand the social engineering concepts as it goes, because we live in our society and the society is having its own dynamics. We need to start working towards appropriate engineering, and we need not follow exactly what's available in the Western market. And what we follow must have its own sustainability, robustness, adaptive sense, and we also should be able to forecast change through our own strategizing of plans, and as well as we should do technology forecast to well in advance plan for refurbishing of plants and do the change management properly. And the bottom line is we definitely need to interface seamlessly with our society. The terminology 4.0 and 5.0 are something we'll explain as we go along. But the whole concept of Industry 4.0, it was coined in 2011 in Germany, was not only about technology innovation, but connection among people, connection among machines, and the growth of Internet of Things, which connect every component to every other component and also to the human being. As we move on further, the Society 5.0 term has come in. I'll explain that also. That's all about collaboration, customization, personalization, and also making use of human intelligence and cognitive computing. So when we enter Society 5.0 and we enter customization, I would like to refer to a small cliche. Some of us who would be well familiar with Nassim Taleb's Black Swan, he has also written a book, The Bed of Procrustes. I always refer this bed of Procrustes because what happened, Procrustes was a mythical Greek being who was a highway robber. He picked up a victim from the road, made him lie on a bed. And if the victim was shorter than the length of the bed, he would stretch the victim to fit the bed. If the victim's legs stuck out of the bed and he was taller than the bed, he would chop the legs off. In either way, the victim died. Now, here comes the point. Do we not, in our education system and all our paradigms of society, we force fit everyone to be of the same length as the bed what we prescribe? We have never adjusted the bed or the training to customize to a person's needs. If a person has a shortfall, we stretch. If he fails, he or she loses. If a person is more creative, we chop it off. So perhaps the bed of Procrustes is the point, maybe the whole world worked on it, but society 5.0, where we personalize everything, is perhaps the first time we're defeating the bed of Procrustes. So we are just preparing now for industry 5.0, and of course the society 4.0 would follow. But let us not forget that at the bottom line, there are the business models, investments, and profits. Unless that is there, people will not really be encouraged to move forward. Okay. Giving a brief on the society 5.0, as you see, we started from hunting society to agrarian society as it grows. But let's see, the significant point is the industrial society, where we have last 200, 250 years. And we would say that mechanization, electrification, automation were the result of, say, 1780s to maybe 1950s. And that's precisely where the society 3.0 benefited from, liked it, and grew further. And as society 4.0 went more into automation and digitization, the society 4.0 advanced itself and participated in encouraging much bigger enterprises, and we got a whole lot of new paradigms in the 70s and 80s with microcomputers, computers, supercomputers, and we entered the age of internet, big data, what have you. And as we move slowly to industry 5.0, society is demanding more, and they are talking of a super smart society. Now, the super smart society would like everything personalized. Whether it will be Swiggy and Zomato to deliver food at home, whether it would be customized education modules to train as per the needs and requirements, or whether medication would be based on pharmacokinetics and pharmacodynamics, that a person needs maybe 500 mg 3 times a day of a particular medicine, but then somebody else, based on his individual tolerance levels, may require 450 mg 3 times a day. Somebody else maybe 400 mg twice a day, followed by 500 mg. So we slowly break down the large pharmacokinetic systems into small drug dispensers where they should get personalized. So this is an example of what personalization means. And so whether it be in field of education, skill set development, training, what have you, everything has to be personalized. And if that is the demand or the lookout for society, Industry 5.0 has to be geared up for that. I think this is an important niche which we have to capitalize, because perpetually, unlike the transport industry or maybe the roadways engineering industry, nuclear industry always required much lesser number of specialized, customized products. They had to be customized, they had to be passed through a large amount of quality assurance tests. Rejections were high, and it had to fit all the safety criteria, what have you. So towards this, we never had an industry who would customize it and give it to us, keeping in mind that the industry would also like to profit from it. So this is equivalent to trying to say that society 5.0, what it is today, nuclear industry was always 5.0, and perhaps we always needed industry 5.0, and particularly in the Indian perspective, when we didn't have a large fallback on supply chain, which I'll not get into the debate of goodness or badness of wars, but which the two world wars, World War I and World War II, had brought in Europe and possibly the US also. So we missed out on the supply chain, and perhaps that's why we kept having problems, especially with smaller components, as I said right in the beginning. Well, having said that, this is Industry 5.0, and we are talking of a supply chain which will go all the way from the construction phase to the generation phase. The pictures used are from the net. I did not want to use any specific picture of our establishments. And I can only say that construction phase, erection, commissioning, all of this require a high amount of specialized engineering. Be it the industrial safety of large size cranes, be it the planning of how to sequence out the commissioning phases, and also prior to that, the erection installation phases. At every stage, we have to do enormous planning, and we have to make sure that smaller components as larger components, all of them keep arriving at a given time, and we need to ensure that the project goes on specified time. Because if the project gets delayed, we lose twice. We lose on the interest paid on the initial money sunk, and we also don't generate power, so we lose out on those revenues also. So it's a perpetual loss-loss situation, which we should convert to a win-win situation by keeping our supply channels very good. I would like to say that we have done fairly well in major operation parts of the plant, in erection strategies, and of course, as we go backwards in construction strategies for the next plant, I think we have done fairly well. We have done fairly well in our analytical development tools, design, what have you. Perhaps the only block today are these smaller components which tend to cripple the speed at which we would otherwise like to commission our plants. So this cartoon essentially tries to give the concept of a supply chain which has a dynamics in the market, the people, the system, what have you. Well, in supply chain management, as I just said, production, research and development, let us manage it well. And the standard products which are easily available and manufacturable, we are managing through the regular logistics, purchasing, finance, and such business. So this I may call it as a level 1 supply chain management. Okay, in this, there are enough reasons to say that we are able to manage well. Maybe very large components also will come under this. And the large, all we need to do is to prod with the larger components, as Dr. Ramarao was mentioning, was done in March, to tell the industry that they also have to line up for our project schedules and timings, yes. But then it still can get done. Problem comes is when you go to level 2, because in level 2, maybe solution design, analytics and intelligence, logistics, partner management is a point to do all these things, network engineering, procurement, these are all the issues. As of today, many of these things we do in-house. Now, can we afford to do all of them in-house over the years to come? Because there are so many developments going on in the market, except they're not aware of the standards which they need to follow to fall in line with the nuclear industry. So can we not at this point stress the concept of developing customized solution? Let's identify all our pain points which trouble us as we go along. And then we try to gather insights from the market, from the startups, the MSMEs, and try to rope them in as either consulting, service consulting, product consultants, manufacturing consultants, whatever. Can we walk the extra mile and give them an idea that perhaps if they do this for us, the spin-offs are enormous? A classic example, long back, a person from DRDO was explaining in one talk in a seminar in 2004, that when the Chinese wanted to develop the microcomputer market, they realized that those days they didn't have a fab. And unless you develop 1 million pieces, it wouldn't mean business sense. So they developed a fab, quality assured only few tens of thousands which are required for high-end requirements in industry. The rest of it was pumped into a toy industry. So the spin-offs which was offered was pretty large, and it helped a business sense, business models, and business to grow in all directions. So when it comes to our nuclear industry, can we strategize these plans? Before I proceed, Dr. Ramarao, am I being heard clearly?
Yeah.
Okay. Yeah. So let's understand what exactly is Industry 4.0. I'll again emphasize for people who have joined late, I'm only trying to emphasize on the small and specialized and customized components. I take the liberty of stating that the large components like the pressure vessels, the cranes, the end shields, and large piping, well, there are significant players in the country. and we are able to manage it. There may be some delays here and there, but we are able to manage it and qualify them through all the quality assurance procedures and testing as requirements are. The pain points are the smaller ones. So if I look at the profile of Industry 4.0, as you see at the top is autonomous robots. And right in the beginning, we realized that if we had to do a main vessel inspection in the PFBR scenario, we needed a robotic device which would crawl through and go to the bottom and then start inspecting it. And we realized how difficult it was to get a manufacturer to manufacture it. Then, of course, the issues of augmented reality as well as other types of realities like XR, which is auxiliary realities, or other virtual realities, etc. If we develop those, we need not do it in-house. There are umpteen number of people in the market who can develop. So can we not make equipment and systems with augmented reality to enhance our maintenance procedures? If tomorrow we have a maintenance team which is outsourced and which works with us only during shutdown of operating plants, they can be first trained in virtual reality and augmented reality structures. Once they're trained, they enter their plant and they do the job much faster than anything else. Internet of Things are available in the market, but we have to develop wireless sensor networks because of security and other reasons. Can we not get persons who are already working on Internet of Things to work as per our requirements and make these wireless sensor networks, wherein we don't end up spending the amount of in-house manpower resources, and our in-house manpower resources could perhaps concentrate more on the larger aspects. Now, as we all know, the area of smart materials, smart sensors, digital twins, virtual reality, cognitive engineering, all these are being taken up by startups. These are engineering growth areas. It has moved directly from academics into startups, and then it will move to industry. Can we not capture some of them? Of course, we need to keep looking into investments, and who would the investors be? We would also like to look into the IT services and entertainment industry. Mind you, entertainment industry is also a lot into big data analytics. They have gone into entertainment because it brings more profit, but that's precisely what we can tell them. A very large amount of analytics go into making, let's say, How to Train Your Dragon, a movie like that, or making something else. But then the same data analytics could be put into diverse uses, and we can harness that into usage. And of course, manufacturing has gone a big way into 3D printing. And there are startups who are entering 3D printing and using 3D printed devices. But can we not get them to harness, get them to work on 3D printing materials, get them to work on 3D printing additives, which meet the requirement of all the safety standards what we talk of. So the whole objective is the entrepreneurs, startups, intellectual services, MSME should help us work towards Industry 5.0 effectively, which is collaboration, customization as the case is. And from that space, they should help us in our space. So I use the word customization and personalization, not just for society, but also for our nuclear industry. I'll also go ahead and say cognitive computing is something which we need when we can computerize our systems more and make them more fail-safe and make them less prone to any human error, what have you. Maybe on par with what the airline industry is talking about. Yeah. Now, let us not forget what would be the expectations of the society in the urban space, because we should not remain isolated, and let us understand that Industry 5.0, there's a huge demand for monitoring of pollution on water bodies. So is the monitoring of pollution in air. And people are already talking of pollution dose on individuals whether they can get. So now we have to work, and we have to convince people that we can have a lot of prognosis and forecasting based on big data from all our existing plants. We are evolving smart controls. We have got smart materials which will give us intrinsic safety. When I say intrinsic safety, maybe we should talk of Curie point magnet-based shutdown devices. We should talk of shape memory alloy-based valves which can fly open depending on temperature changes. Of course, in the fast breeder context where the temperatures are higher. And we should try to make a nuclear reactor core as safe, let us say, as a pressure cooker. Why do I use the word pressure cooker? If you just put your mind a little, you'll realize that the weight valve of the pressure cooker is a sensor because it senses pressure. It's an instrument because it causes a relief. It's a part of the process because it can't work without, the pressure cooker can't work without that. And it's so accurate that millions of households would put something on a pressure cooker and go. So if tomorrow we are to bring in an intrinsic safety concept in our nuclear reactors, and of course, as long time back, people said once we make our containments very robust, then perhaps we can think of planting our nuclear reactors right in the middle of the urban space, with the society not feeling anything about it. And then the supply chain problems also mostly will be solved because the transportation problems are solved. And we can always say that we are much less polluting than the various other sources of pollution because we are essentially a green industry. But then let's get society into our side. And only we have to meet their expectations in the urban space, and then perhaps we can do it. So what does this Industry 5.0 promote? It promotes a human-centric talent, diversity, and empowerment in the society. This is no more procrastinator's bed. People want to get into their own space. It promotes a resilient society and, of course, promotes sustainability. When I talk of sustainability, let us also remember the Sustainable Development Goals of the UN, which talks of the number of measures which are required, starting from poverty removal to industrialization to decarbonization and whatever. So in the process, society's expectation and the startups and small scale and other industries are working on a cyber-physical manner of working. Can we also not capitalize on that? We can reduce our ALARA limits. We can get robots to work in the internals and get many jobs done during preventive maintenance. We can work together with robotic devices to take care of ALARA, as I just said. People are working on exoskeletons, where effectively a person's load carrying capacity will go up many folds. It has got an enormous benefit for societal application, but I view directly as a commissioning problem in nuclear reactors. But even if I have to shift a 50 kg equipment, I need a chain pulley block, or I need to call riggers, and they have to make some contraptions to shift it from one place to another. Perhaps with good exoskeletons, with a rigger who is trained, I may be comfortably able to lift even 100 kg. And that's enormous time saving because a person gets into all this. It's a different matter if that thing gets contaminated, what happens? But I'm just trying to say that we need to think of it. And we need to really think that how to augment intelligence in the control rooms and in the computers such that we get into neurocomputing of the brain, augment intelligence of the people, and have a cyber-physical collaboration between the concerned engineers in the control room so that you reach a situation which is far more safe. It is something like this. Boeing Industry and Airbus have perpetually been working towards whether to make the pilot supreme or the computer supreme. Airbus industry had evolved that perhaps, if the pilot can have an emotional problem. So if they have an arbitrary set of computers which guide the pilot in case their onboard redundant systems have a problem. So these are some of the areas which world over people have been discussing and developing. And in nuclear industry, I'm sure with this augmented intelligence features, we can make the entire control room much more smarter. We can make the design planning smarter and operations also much smarter. And we can claim safety to a level which is much better than maybe 10 to the power of -6, what we target to do even better than that. And once we do that, then the public comes on our side, the people at large comes on our side, and we move forward with this. So can we think of smart startups, which will help us develop customized designs, development, fabrication, and all these are multidisciplinary. And can we all pitch in to see that all this comes on our side and we are able to rope in all this with, of course, our requirements. But let's keep in mind, unless we have the investors in place, and because for perpetually we may not get a support only of the government in power, we will also require to generate money from the market. And we can do that if our safety standards are impeccable, If our availability factors are very high, we can earn from revenue, and that should be the ultimate way in which the entire nuclear power industry is to go. It's a different matter that we need to get into a competitive mode with renewables, and we'll have to see how everything proceeds as we go along. But it's very important that we become self-earning. And to reach that self-earning stage, not only do we convince society that we are safe, we also convince society we are green, and we convince society that our availability factors are as good or even better than not only fossil but also renewables. Perhaps this would be one of the ways in which we can take things forward. I'll just add something else, because the society's expectations are a little different as we move along. They expect office spaces and cafeterias to fall in line. They expect reduced office hours, and that should be done without productivity. They want to reduce travel times. Recreation space, cafeterias should merge together. Then we should be able to operate a process plant or manufacturing, maybe sitting at home or sitting in the comfort of the office. And naturally, this will be an increased use of SCADA and XR tools, but not just increased use of SCADA and augmented reality and virtual reality tools, but they have to now get qualified with a complete verification and validation. But I'm sure we can do it, because the whole idea is we should start thinking that this could become a requirement. And once we start doing this, maybe we're better off. I can address one societal issue which year after year in the plants I've seen. Who operates the shift on the Diwali evening? It's always a perpetual war as to the crew which will operate in the 3 o'clock to 11 o'clock shift on the Diwali day. Similar, and then very often than not, what can happen is somebody doesn't, the reliever doesn't turn up. So now if I can make spaces and I can increase automation, I can talk in terms of more augmented intelligence. Many of the societal things also could be met. And all these augmented intelligence strategies can be fitted into our plants. But yes, natural question will come is safety. Of course, we have to address safety. I mean, the whole human society has addressed safety ever since Industrial Revolution days. So we have to make our codes and guides and gather them. They do cost money. But as I said, if a large number of brains come in and large number of startups who are making this for a commercial space come in, all they need is to add another 10, 20, 30% of their costs, which we should be able to pay, and bring in all the safety features which the regulatory, nuclear regulatory conventions actually require. So the other part of which is important is there's a lot of work in the commercial space for geriatric patients and also for senior citizens where the home interiors are expected to change, where the cyber-physical systems would actually start working on the home. Now, let's just give it a thought. What prevents a malfunction in the software for making the robot strangle the baby? So that also meets a safety standard. What prevents the robot from, instead of massaging, to just break the neck of the person? Now, such a thing has happened in case you have read the news item. A person was playing chess with a robot in China, and he made a move before the robot could, and the robot broke his finger. So now the point is, all of this, these are certain furnitures, all of this must go through safety. So as of now, as we are entering this domain, even for domestic space, we may require a formal code and formal guide to decide on the safety standards, decide on the quality standards, decide on the software standards and hardware QA and what have you. Just like maybe not to the level of nuclear, maybe not to the level of aerospace, but definitely to the much beyond the commercial space. So these things are going to come up, but as society moves in this direction, definitely a lot of people are working on such cyber-physical ambience, making such robots available, and they are quite conversant with these technologies, which we can harness for our own use. So as we see, we need to make a whole lot of policies in place, including the legal systems for technology, as well as for human resources, for social acceptance, and we should conform to technology, societal, regulatory, and policy interface. So maybe the technology for Industry 5.0, the entire operating standards protocols need to be drawn up, safety standards need to be done up. The design studies for homes, factories, transportation, etc. has to be translated effectively to our industrial ambience and nuclear ambience. When we make reconfigurable systems and equipment as per individual requirements, the same things could be slightly extended to form the requirements in the nuclear industry, especially wherever you have higher radiation areas where LRA tends to get violated, where we can reach a situation where practically a person doesn't get a dose who otherwise would have got their minimum dose. And of course, naturally, we need policy formulations for homes, industrial towns, town planning, etc. on one hand. So naturally, we can extend these policy formulations to see how this bridges with the regulatory codes as existing today. But we shouldn't forget that with all this, we require a paradigm shift in education 5.0 and skill sets 5.0. And naturally, all this will help us evolve better cyber-physical system standards, hardware QA, software BNB, whatever. Well, going forward, perhaps some of the biggest enablers of Industry 5.0 are exoskeletons, which I mentioned, should help us in rigging and increasing or rather decreasing the commissioning or erection time. There'll be a whole lot of activities which get delayed by hours, days, sometimes weeks because of lack of space for putting chain pulley blocks, which can be done with people with exoskeletons. And I don't need to move a large crane for that purpose. A large number of small fabrications which can get fabricated and fitted into place could be done by additive technology, provided, of course, standards with respect to the additives, the material used for such type of 3D printing, etc. we need to do. 5G is another commercial space, but where communication standards also can be fitted in to have better wireless sensors or IoT devices. A standard thing that Dr. Ramarao is aware, we are discussing with IAC on plugging in sensors right in the structure of the civil structures, which have IoT devices. With that, we can actually find out the degradation mechanisms of the containment building. ISC Bangalore has been working for the railway bridges and other civil bridges along with SCRC Chennai. We were engaging them to find out whether the same thing we can do for the PFBR containment in terms of aging management. This is an important area because aging management, and if I can make the reactor operational for more than 80 years, I can actually get a financial benefit in leaps and bounds. And perhaps most of the things are all right, provided we have the technology to support it. So, and of course, the industrial blockchain could come in to help for cybersecurity, mixed reality, as we mentioned, to train people well in advance before we shut down the reactor. So we can squeeze the shutdown to smaller and smaller periods because people have already been trained in the specific areas. We have also allowed the mixed reality to help people decide how to sequence our maintenance action during outages. And thereby we find a method of increase our profitability by reducing the shutdown, improving availability factors. Drones, of course, there is enough and more evidence to say we can make the drones go internal, and we can take a view of a number of parameters in the so-called inaccessible areas where on-power entries can be avoided by use of drones. Okay. Now, the whole idea is fitting all these requirements into nuclear industry, and we need to augment all this design, development, manufacturing standards to reach what is known in the market as SIL 3 and SIL 4, Safety Integrity Level 3 and Safety Integrity Level 4. These are the way in which PLCs and other computer hardware is sold. Nuclear standards are usually SIL 4. In India, of course, we have our regulatory standards where we conform to D25, D10, D20, what have you. But essentially, we are trying to meet internationally acclaimed SIL standards of 4. Like, for example, a metro rail would use SIL 3 for the door opening in case a person gets jammed, and braking of the train, they may use SIL 4 if they can afford it, or they may stay with SIL 3. So these are questions of products which have gone through a hardware QA and also gone through intense software verification validation. Getting some idea on the skill set development for controls. Like today we have connected machines, so I need a control 4.0 and we should gravitate into control 5.0 because when we focus on delivering customer experience. Here, instead of considering customer experience as the term used by Swiggy and Zomato, let me call our customer as a specialized person who needs specialized equipments. In which case, whatever network-based controls are there today should become reconfigurable, adaptive control with artificial intelligence and machine learning. We need to qualify them both by software and hardware. Mass customization was done earlier by reconfigurable control. Today, it's hyper customization. So maybe we can have a better adaptive control suiting different equipments in our own plants, and different equipment, even backfitting thing could be done by 3D printing, reconfiguration, maybe by AI, ML also, VR, AR for trading. And of course, the intelligent supply chains can have model predictive control to see that delays don't take place. And we have model predictive controls with AI, ML, smart products, materials, sensors, all this which are available in the commercial space can be customizable, reconfigurable, both from robotic point of view. A robot, for example, could squeeze itself and enter a narrow port and again open up with a temperature difference, made use of shape memory alloys. So one can give all these things a thought as robotics and automation moves into coordinated, collaborative, and hybrid controls. See, there was a time when manpower was distancing from factories, but today they want to participate. So if you can participate, if you have hybrid controls and you have a cyber-physical system which go in place. So as we said, we need to augment design development again here. See, one more thing which has given us a very big advantage is the large volumes of data. So when I say large volumes of data in our nuclear plant, we always talk of a specific process loop and do data on that. But can I connect the entire plant data and try to put it under the mold of a very big data and try to do not only process control, what I mean is the power control and PHT control and other controls. I also mean I can talk in terms of assessing the human beings and what time they should come, have customized shifts in place. Maybe some people's shift can be made longer to have a job done better, and then the person gets proportionately rewarded or penalized as the case may be. So, there are the entire society 5.0, industry 5.0, and nuclear industry can work together. And in the nuclear industry particularly, apart from the three main V's of data complexity, we have veracity and value to really take care to ensure that the data is of good quality. And for the skill sets, we need a whole lot of math of Industry 4.0, which deals with automation, connection, cloud, Internet of Things, big data, integrated systems. So the skill system, the skill development is all about data analytics. We do need to now induct people either as full-time, which may not be required, or as outsourced partners in our system, whereby we can have, sorry, I think some problem with the, okay. Whereas we can have consultation coming into picture and helping us. Confidentiality, yes, well, various countries abroad have defense departments also having consultants. Even we can rope them in with the right amount of confidentiality of data, with the right amount of inputs, and help them build ourselves and participate with us. In the process, we'll get every one of them together in our entire enterprise. This is one more area which the defense departments, as well as various aerospace departments and air pollution departments are working. They are using large hazard mitigation due to toxic fumes drifting in. They are looking into aeromagnetic surveys. They are looking into space situation analysis. This also is an area where we need to help people generate environment analysis. We do have a very large pool of health physicists which work for nuclear industry. They are pretty much experts in atmospheric plume, atmospheric dispersion, hydrological dispersion, with some additional training, maybe with geological site surveys, maybe with atmospheric plume models, with some more training on how SOx, NOx goes in. So such people can be roped in with us, and we may use the common expertise of people who are working on space situation analysis, doing aerial survey. We also have expertise in aeromagnetic surveys for strategic materials. We have a variety of technologies available under our umbrella, which we can share with the public domain and get people to participate, because otherwise it will be impossible to rope in that much of in-house manpower. A standard example perhaps could be, it's not that we have not been doing. I think a large amount of people are, or through BRNS projects, have been mapping and doing a variety of survey in Kalpakam coast, as well as the Kali River next to Kaiga, as well as in the Thorium sands of Kerala, where large number of data collection is being done by local university and college students, and they form a big backbone to give us data. Perhaps these models are already existing with us. We need to extend it to a different space, match it with the requirements and expectations of Society 5.0. When I say Society 5.0, I mean the bright students coming out of university, developing engineering gadgets and devices for the commercial space. Let's capture them. Let's get them and drop in our side. We tell them, you please go ahead and do your commercial work and make your bread and butter. But you do work for us, you help the country, and also you add an omelette and other things to your breakfast, which enriches you. It doesn't get you down. So I suppose these are added things which you need to do. So for this, let us go in for a data-oriented management or ERP. So this also is an important thing, because NPC, of course, in a very large scale as a corporate management. In Bhavini, in a miniaturized form, we had our own corporate management, where we perpetually tried to calculate what would be the electricity bills of the PMBR in future. We had multiple discussions with PMO and Finance Ministry on fixing of electricity bills, and how much concession to give to lower your IRR, how much would the dividends be. All these things will all come into picture. So we need a lot of data, information, etc. So we do need very good process control. I'll just clarify the term. Here, the process control is nothing to do with a mechanical or chemical process. It is the process of a corporate management strategy or the processes of office management strategies. So here we have to do a control system for a control strategy for life cycle management, and we have to do some predictive control strategies. All are based on the distributed data, data ontology, data mining, all things which come. And perhaps we can think of good consultants in the area who can help us build up. And we can eventually make an ERP and also a HR model with people capability maturity model. This has been introduced in our both the corporate sectors of NPC and Bhavini. And since we did not want to outsource it because of the strategic nature and the confidential nature of our data, we have formed a committee in-house to have develop a proper people capability maturity model. This is the rough idea of the model. I don't know if Kelkar and others are here. They are part of the whole from NPC. Then they would know that we had all our nuclear powers essentially were well-managed plants. So we started at level 2 and we're moving to level 3 in most of the plants. But perhaps the whole objective of the people capability maturity model is to lead it up to change management or level 5, which is the optimizing model. So this also requires a good amount of expertise. In case we always don't have it in-house, we can get from outside and get the whole system robust enough to develop the people capability maturity model as well as work with big data. So these are also areas, because unless we collectively attack the technical space, the managerial space, the human space, all in the perspectives of today's society 5.0, it will be difficult for us to have a robust and versatile and progressive growth at all times. So we do need to manage all the fronts. So one major point is Government of India has announced Skilling India, and various government enterprises have been appointing people for a short time for skill development. Now the point is, can we do an increased industrial employability by digitizing, which earlier, as we said, when we can improve our operation maintenance practices, because all the physical assets can be digitized. When I say can be digitized, the physical assets continue to remain. It is, I have a digital equivalent available with me to play on. When I say digital equivalent, I don't simply mean some set of parameters in the computer. I mean a complete holographic image or even a 2D image where real-time data keeps coming in and helps me to play around with the physical system. And that is called a digital twin. So as you can see in the image, maybe a simple motor can plug in its data in a holographic image, or at least in a 3D image. To make these things, of course, I need a lot amount of codes and FEM models and 3D modeling. I may need virtual reality software. All these things I do need. But all this, I have an application or user knowledge with that we can do. So this is some sort of a rapid prototyping. I have this with me that, as you see, I can use data also to use all the bind data and create a digital twin. I can make it by using a physical version. I create a digital version with some analog data. I get more digital data, and I finally have a digital twin to play around with. The importance of this will come in the next picture, is when you see there's a virtual reality model next to the pump. There's a simplistic model. The intent of it is I can play around with this when the system is operating. I can cause it to go to AOOs, anticipated operational occurrence. I can create a trip. I can change set points and find out the vulnerabilities of this equipment. This equipment is just a standard, a representative equipment. You can consider to extend it to any level. And this one would help me get complete knowledge and training of the original equipment. So once an outage takes place, the management of it or the repair of it is extremely quick. And this, if you see, can very well be done to match with our Skill India philosophy, as well as our in-house training, as well as with hired manpower during outage management. All these paradigms can be addressed by suitably strategizing our digital twin development for this. Just to give you an idea, the aerospace industry has worked on this quite a lot. It is like this, like when an aircraft leaves Chennai and has to go to Delhi via Bombay. By the time the aircraft is airborne from Chennai en route to Bombay, the entire engine parameters are continuously monitored in Bombay. And a decision is taken that these are the parameters which require tweaking or adjustment in Bombay. So the turnaround time is drastically reduced, because in the 1.5 hour flight time from Chennai to Bombay, the people are ready with the tools and all other software deliverables or upgradables, whatever you call them. And maybe a turnaround time of 20 minutes or half an hour would be good enough. The same time it takes for some passengers to exit and enter. Earlier, the turnaround time could be more than 1 hour. So by reducing the turnaround time with the help of understanding digital twins, with the help of preempting what sort of maintenance activities are required, you have actually improved profitability of the airlines. Now, this would be a typical way in which you can represent a physical asset with a digital asset, and you can consider doing the same for our own industry. I've just shown some representative pictures where you can identify the models and decide what are the interconnected loops. I can evolve operation and maintenance skill sets. I can work under, of course, appropriate guidelines. And this is a real-time simulator in which I can plug in all the real data and I can keep adjusting. So for the time being, I can think of developing a digital twin in a simulator where I not only simulate, I use this as a simulator function under normal conditions. A digital twin function prior to a maintenance function or prior to doing something on the plant or prior to understanding the plant transients better, I can use it as a digital twin function. The same thing would work for reducing human errors, because I can actually incorporate a whole lot of data and event logs, field notings all into the simulator, and I can work on predictive output on various systems way ahead before the actual plant gets into a problem. So the digital twin helps me to understand the potential area where I might make an error. So I can actually mitigate it before an error can take place, and thereby I can remove the possibilities of an error. So just giving you some idea, this sort of representative plants can be directly plugged in with IoT devices. All the parameters can be superimposed, and perhaps all these things can be given to certain specialized people. You may see in the market, today we talk of full stack developers in IT industry. We talk of cloud engineers in IT industry. When I say IT, I just don't mean the database type of people, but people who are involved in the commercial space for doing a whole lot of IT-related work for, say, bottling plants, breweries, small-scale industries, MSMEs, whatever. So the advertisements are full stack developers are paid this much. The cloud engineer is paid this much. Now, essentially, a cloud engineer is requiring an expertise for the IoT. He sends it to the cloud. The cloud does the computing and gives back. The cloud has a partition. Now we need to impart the necessary safety training. We need to impart which sort of cloud they're using. Maybe we can have a customized cloud or a dedicated cloud. Maybe we can train them to see that no data gets corrupted or hacked. So we can talk of reliability in cloud computing. We can talk of scalability in cloud computing. And these full stack developers are essentially the software developers given a standard hardware. We can give them all the trainings of VNB and we get them on our side. So we have a plethora of people, a large number of people working for us without making an attempt to develop everything in-house and also deal with attrition problems and variety of such other problems. So we have got into a common mode now of making digital twin to reduce maintainable time. To develop these digital twins, we have got into consultants. We are getting consultants who are into cloud computing and full stack development. We are getting into consultants for doing simulators and also database processes. And we find that we can develop digital twins even for large plants. So we can even take unstructured data from the event logs. We can work on cyber physical domain analytics and event systems. And we can actually help in getting this done along with our in-house participants who can do it. So this would be a method in which we can reach out and get these things done. An added part is I've just shown how the control rooms have evolved from Gen 1 to Gen 4 type of control rooms, where essentially ergonomics, aesthetics, and also information overload paradigms were really looked into. And modern control rooms have gone into intelligent data processing. But the whole aspect today is what we discussed at the beginning, is an augmented intelligence. So if we have to enter Society 5.0, we need to enter the domain of neural computing and applications and augmented intelligence. The intent of augmented intelligence is an individual's knowledge in the control room is supplemented by the computer. It is not substituted. So let us say an EOP has to be executed, an emergency operating procedure. Instead of alarms, you have alerts in the control room. A sequence of burst of alarms which a concerned control room engineer fails to evaluate with that speed, the computer evaluates, looks at the sequence, takes a decision that this particular equipment or system or process might be reaching alarm levels or trip levels, and it gives you a set of solutions which is suggested. So you apply your own knowledge and you apply or look into the augmented intelligence provided, do that together, and then you come up with a solution which is much faster. So you can well see how machine intelligence works when you do a Google search. Before you complete the word, it pops up. So your augmented intelligence also could have additions which keep coming through neural computing. And we can keep developing an augmented intelligence just like experienced operators develop a complete knowledge of the variety of EOPs which can take place, variety of AOs which can take place. So this sort of, we are bringing towards something like an error-free type of operation as we move forward. So, of course, once we talk in terms of augmented intelligence, the softwares are pretty complex, and we do need to factor in a whole lot of regulatory requirements if we have to make it available. These softwares today are used more in the banking industry, in many supply chain managements, but not for very critical systems. So, the decision-making, problem-solving, anticipation, large memory, and also understanding natural language, computer vision, all these things, entire thing can be put into a regulatory framework where not only do you use the cognitive data, but you evolve safety and regulatory requirements from the brain center. We may be aware that there was a brain center earlier in Delhi, and just a few months back, a brain center has been started in IIT Madras, just next to the building where I'm sitting, where people do a whole lot of analysis on neurocomputing and do a man-machine or human-machine interface studies. And they're also looking into factors how brains rewire themselves. Because if one sensor is a bit down, then the other sensor gets augmented to compensate the human body into working as normally as possible. So perhaps the artificial brain and the augmented intelligence software which builds an artificial brain would help us in reaching an error-free type of operation. Well, the most important part is, are we doing enough for skill sets? Because the entire skill sets are taking a complete paradigm shift. And perhaps among the good things that has happened with COVID, I'm never saying it was good to have COVID. Among the only plus point is a huge amount of online interchange of knowledge. Perhaps if it was before COVID, I would have traveled to Bombay to give this talk, or you would have thought you'd call somebody else, why get somebody from Chennai to give the talk. But because of COVID, perhaps we have agreed that on a webinar we can talk. So because of this, we can actually try to reach out to numerous people in the rural space where digitization is going on in a large scale, and we can get education spread in a very large scale, not only through normal digitization, but also making augmented reality and virtual reality available to them to get a real feel of what is Industry 4.0 and 5.0 helping and benefiting them. So perhaps the earlier concept was essentially academic and basic research institutes and all went there. There are a few customized academic programs and customized training modules, which has now got strengthened with Industry 4.0. It will get further strengthened as we go forward. We'll see how. So if you see in Industry 4.0, a lot of startup MSMEs and soft industrial units were coming up. But now with more and more online type of study structures and skill sets, and Society 5.0 getting completely lined up with higher education modules and systems, we may slowly move into an Education 5.0. I will share with you a debate which is going on among a lot of academics, that whether we really need to train everyone to get into absolute fundamentals. Because a half or more people would like to rapidly use tools which are available and solve a problem. So could we not think of reducing the time for education system where a person is mainly taught to use the tools with some rudimentary knowledge, and then let him not ever leave the institute. Let him go to industry, come back after 5 years, reskill himself for maybe a year, again go back, and again come back after 10 years. So you are a perpetual student of an academic and industrial system. I say student of both, because you leave a system, get yourself into the industry, work towards productivity, come back, reskill, and go back. So I suppose this would be the trend which will be happening over a period of time. And with more and more virtual reality, augmented reality, 3D printing, and various other tools of online education systems being available, multiple tools to solve multiple problems being available, it is but natural that we can get people trained much faster. And of course, with augmented intelligence growing, I'm sure a person can get trained much faster. And of course, the point of reskilling, as and when a person feels like getting himself reskilled, or a person feels the need of getting reskilled, a person comes back. So the whole idea is training in Education 5.0 is all about knowledge, competence, and skills. And we need to get people with these three concepts of skills, knowledge, and attitude to get a superior job performance. So the knowledge, tasks, and attitude with the competence is what defines a competence training as against a classical education-based training. The point is, if today in the rural space, a person had no benefit of doing a graduation in arts or commerce or even engineering, in future, with maybe a few years of schooling, followed by a competence training, he or she is confident to repair an agro equipment or an irrigation equipment, and he gets trained in a number of electronic devices and gadgets, he becomes employable. He or she becomes employable. You imagine the status of an Ola or an Uber driver. They say in India, all what is required is he needs to know a smattering of English, and after that, he's given a short training on Google Maps. So his employability has become multi-city. He doesn't need to know the city. You go to any city, he has a Google map in front of him, he has a taxi, he has a driving license, and he drives you whichever place you want him to go. So the skill sets on one hand has changed enormously. So on one hand, when Industry 4.0 was claimed to take away jobs from people because many things were getting automated, a whole lot of new type of jobs are coming and filling the space for getting people. As a matter of fact, maybe 10 years later, many younger people would be doing job which does not exist today. So that's precisely the way this whole system is growing, and the time is ripe for us to capture this. We also get people trained extensively, but then can we not train them early? Can we not get people trained purely in nuclear plants, a variety of these methods, and they get trained into our system and they fit into the system very well and generate an error-free service? So if you see the development format in Industry 4.0, the word customized is replaced by personalized. The academic and basic research institutions are now put in dotted lines because they are hazy. They are meant for some people who want to become, earn a lot of degrees and think and get themselves into a different space in society. But for an average individual, all he or she requires is a quick and personalized skill development. With the skill developments in space, the same startups and MSMEs which are coming up earlier would occupy a much larger space in society. And all the personalized skills would be used for startups and MSMEs, and all the specialized and personalized issues and training what we got could get actually used. Because let's understand a startup. Do I need a high-end education, or I need a person to deliver a product which you require, product or service what you require? And to understand this, perhaps if you train a person with a personalized skill, not only do you skill a person, but you also give enormous confidence to a person to move forward. I'm of course not talking of the business models and financials which get into all this. Even that will be part of a specialized and personalized skill set development. So as we slowly conclude, perhaps we need to dovetail our startup growth engine with the techno-commercial forecast. We need to just, as a nuclear industry, perhaps we can monitor what are the directions and growth of the new startups, where all this industrial, commercial, and societal space, how it is getting filled. The monitoring and assessment of patents, investments, and financial returns. And we also see whether many of these startups and many of these small-scale industries or the MSMEs which are coming out of all this can be safety upscaled or can be industrial upscaled and can be having a fitment, can have a fitment to our requirements, and what is the way forward in which we can get them trained to develop for us. So can we develop such technologies? Because technology is common. It's only the quality. It's only the good engineering practices. It's the safety paradigms. It is only the industrial ruggedization which needs to go into it. So can we do all that and do the characterization accordingly? And then also look into the technology forecast or technology changes. Like for example, in my lifetime in BARC, starting from 84 when I joined training school, I've seen one level of complete refurbishment of instrumentation. Perhaps if the lifetime of the reactor goes up to 60 years or 80 years, you'll have 2 generations working on the same system. But the instrumentation systems may change every 20 years. By the time I retired from the department, it is felt that the instrumentation systems may need a change every 15 years or may need to get augmented. So the design planning itself has moved to keep adaptable modules which can be augmented to the existing system so that the instruments or the control instrumentation system per se can match with the changing times. So I need technology forecasting. So technology forecasting has to take place at every level when certain think tanks have to look. What way do I do my inventory control? In what way do I keep provisions for replacing? What way do I keep provisions for augmenting and what have you? And how to speed up and how to modularize and how to train people accordingly. Because as technology changes, people also have to change and the mindsets have to change. A simple example I recall in 2010 when we changed the control room panels in Dhruva. If some people are Dhruva attending, they can supplement the knowledge. It was done panel by panel. And when things were getting changed, we found that the older people were preferring the direct visual indications rather than pull down menu-based indications. So there was a paradigm shift in the way we think, when the earlier people worked more on memory as where a particular indicator is, as against a younger generation who is very quick in doing a drag and drop menu, a pulling down menu, be it on his smartphone, be on computer, what have you. And we also saw that different crew members had different ways in which they could configure a smart recorder or a computer screen. And this is continuously changing. So I suppose it is important that not only do we do technology forecast, we do forecast of the generations as they come and understand what the gaps are and try to bridge in the gaps and try to factor in the gaps. Of course, keeping in mind the safety and regulatory framework, that will remain constant, because safety, human safety, industrial safety, nuclear safety, and all other safeties always has been paramount. And I suppose that we have to get them straight. But that's a marginal additional work as compared to the fundamentals. So the point is, this is where we are. We have to harness the complete power of Society 5.0 in framework of industry, combined with education, and that's where we stand. Well, thank you for your patience. I think I managed to stick to 60 minutes.
Yes,
not too sure.
Absolutely, absolutely.
Okay.
That was a wonderful presentation. Thank you.
Thank you, sir. Thank you, sir.
Thank you very much. And we can take a couple of questions. Ramanamurthy, are there?
I'm here. Yeah, there is no question as of now. So can I ask a question?
Yeah, please go ahead.
Yes, yes, please.
Yeah, Dr. Roy, this is really a mind-boggling array of technologies which you have presented today. What I wanted to know was how well we are, our society is, how well prepared are we to transition into this kind of a paradigm, and will it lead to redundancy? The sense, will more and more people become irrelevant, and how do you upgrade a large number of people to a new paradigm, a new regime? So is that going to be a fresh challenge?
Can I answer that now?
Yeah.
See, I think my last slide, I talked of skilling an individual with I 4.0, digital skilling an individual. So I do agree, like if you go to Bangalore airport, you'll find that there's no baggage handler. You take the tag and put it on the conveyor belt. So but then at the same time, there's a huge amount of skill sets getting, so those handlers' jobs may get lost. But then the space is getting created for a person who has skilled himself or studied only up to 6th grade or maybe up to 10th grade, and then did a 1-year crash course on skilling on industrial repairs. So the space is getting filled by such people. So jobs are not getting lost as they're getting created in the lower segment. In the higher segment, you should just come to IIT Madras Research Park to see the number of startups which are blooming. And all what I mentioned are all I can see happening here. In fact, one part I did not mention, since you asked, may not have direct relevance with nuclear, but it still has a relevance because we have a medical Tata hospital, etc. The amount of medical technology and medical equipment growth where startups have come up. They are directly liaising with doctors and working. I'm directly participating with an air pollution monitoring startup. They are in fact tied up with hospitals to find out personal dosage of air pollution and how it affects tuberculosis patients, how it affects childbirth ladies, how it affects cancer genomics. So these are the type of collaborative, data-based and pollution-based work going on. So towards this, people are talking of mobile sensors, which are mounted on rickshaws, bikes, etc. It goes in various parts of the city and captures air pollution data. People are already talking about tying up with international universities, making postural changes with regard to furniture for geriatric usage. Like as people grow older, their knees give problems. So the chairs have been made higher. I have a digitization with which I can raise and lower the chair, and that too should come at a cheaper cost. Similarly with beds. Similarly, so you see there are umpteen number of growth which is taking place in the commercial space, domestic space, as well as perhaps in the entertainment space and in the small scale industry space. We need to just sort of get these things in order, push a safety standard and a regulatory mindset into them to better engineering practices and quality, and we have the product what we want. I hope we have answered the question.
Yeah, partly. We'll maybe have a discussion later.
Okay.
Thank you. Thank you.
Yeah. Any other questions, please? Yeah, Mehta sir.
Yes.
Go ahead. Mehta sir, go ahead.
Yeah. So, well, first of all, congratulations for your lively lecture.
Thank you, sir. Thank you, sir.
And delivered in a lot of enthusiasm. But I have few observations. One thing is this is a developing science. It will very much depend upon the quality of the input data. Even though you have said that you will be having online corrections and input there and also the things like that. Second is the model that you use, the validation of that. It will be a big challenge because expertise are very limited available. Then the failure analysis. In the whole process, you have to do some failure analysis. And then the last thing is that one, if you want to do a regulatory aspect, expert available in the field are so limited, it will take a tremendous amount of time. But I wish about the kind of approach that you're doing, that one kind of a technology that is coming there, it has to take over in the future, and we have to work on that direction. Thank you very much.
So can I respond, sir?
Yeah, please.
Yeah.
Sir, I would slightly differ in that point of expertise, sir. If you see traditionally, let us say an instrument, let us say a pressure gauge. I can get a pressure gauge for 1,500 rupees. I can get a pressure gauge for 15,000 rupees. I can get one for 1.5 lakh also. The principle would still be the boron or the capsule. Perhaps the only difference is the quality of material, the quality assurance procedures, the calibrations of that, testing of that, and which makes all the engineering practices which go in, make the whole gauge ruggedized. Now, the same paradigm applies to electronics, the same paradigm applies to all other industry, but technology per se, or technology which is just a product per se, may cost X, but if I start ruggedizing it, which is not adding technology, which is just adding knowledges and testability in the system and doing much, much more of testing, that adds to the cost. That we will bear. But I think the technology is there, sir. We need to apply all the safety practices which will envelop this technology and make this technology into a rugged technology suitable for us. I don't think we need to spend a lot of time getting expertise. We need to take the existing expertise in good engineering practice, put an umbrella on the new technology, apply all the practices, and we'll have the robust and the rugged system. I mean, this is the way I put it, sir.
Can I ask a question, sir?
Yes, sir. Yes, sir.
Please go ahead.
Yes, sir.
Sir, under flexibility, resilience and flexibility, anyway, it was an excellent talk on Society 0.50.
Thank you, sir.
Under resilience and flexibility, I just want to know how much flexibility is possible in government organizations?
Quite a bit, sir, if you really see.
I just give an example.
Yes.
Recently, I had supplied one special material called nickel calcium to some defense organization. There's some specification, calcium should be 5.0 to 6.0. But I know master alloy, even with little flexibility, can be used. But nobody can take a decision if it is 6.10 calcium. So you don't, can we really, inventor will say, or the committee will say that did not as per the specification. Material is not made in India. Whether any flexibility is possible to adjust in certain critical situations. I just wanted to know when you're talking of indigenization, all those things.
Sir, I will give an answer. See,
Yeah.
all over the world, sir, nuclear and aerospace industries are 10 to 15 years behind commercial and transport and other industries. That is because nuclear and aerospace industries all over the world wait for proven reliability and proven testability before using any equipment or materials, whatever.
Okay.
In addition, the gestation period of construction, if it is 5 years, certain equipments or certain materials would have undergone type tests at the first year. Then the design cannot be changed because of safety protocols.
Correct.
So the point is, if at all a newer technology is coming up, it has to be attempted for the next project. So towards that, sufficient number of tests have to be done, sufficient number of proving things have to be done, and then it gets accepted. It is not that it cannot happen. It has a larger gestation period because of the type testing and because of the extensive validation which is required to qualify it for a particular safety use. So I think only it's a matter of a bit more time. Unlike commercial industry, which can accept it in a year's time, nuclear industry may take 8 to 10 years time to accept it. So that's the only thing.
I was telling you where flexibility is possible, whether it is really possible to have a relaxation. Just I wanted to know that. Where flexibility is possible.
So flexibility and relaxation are two different terminologies, if you permit, sir.
Okay.
When I say flexibility, I'm trying to say I'm changing a technology, but there'll be no relaxation in terms of the standards. Okay. Let us say today I follow a verification validation standard as per the code. And today you give me a software which is working on a different principle. I'll still subject it to all the standards and codes. Similarly, with if you give me a new microcomputer as against an old one, I'll subject it to all the testability as existing. So that is not relaxation. That is flexibility. Relaxation is sort of condoning a few parts of the code which you feel are too stringent. So that one may not be willing to take the chance of condoning a part of the code. But yes, if you prove it, then it will be acceptable in the next project. It's not that it will not be acceptable. It will be acceptable in the next project. So with the delay, with the gestation period.
I'm telling you, if you are able to prove it, I'm telling.
Yes, sir. But that goes without saying. See, sir, like a person had come to me saying that he has developed swedge lock fittings in India. It meets all the standards. So naturally, I told him to get it checked with various people, and they tried all the things in addition to them. So at some point of time, maybe few more years' time, he'll be accepted as the equivalent of swedge lock. So I see, once you meet all the quality standards, once you meet all the engineering standards and all the safety standards, there is no reason, but you have to prove it. That's the only point.
Oh, thank you. Thanks.
Yes.
I have one small clarification, Roy.
Yes, sir. Yes, sir.
Are you trying to emphasize the point that this industry 5.0 is now in a wider sense applicable in MSMEs, but not in the larger industry?
See, industry 5.0 has been conceptualized just last year, end of last year. Before that, it was industry 4.0. These are just matter of terminologies, but the bottom line is like this, sir.
No, even 4.0. 4.0 is our industry, the heavy industry. Are they still able to categorize them?
No, I'll tell you, sir. See, 4.0, for example, if you look into, say, a metro rail project in India, most of the metro rail things are following IoTs. Again, it may not be for the braking if there's an obstruction in the line. There, if you have to follow SIL 4, you will not follow the IoT. That is Internet of Things. But all other aspects is following. So they have got a graded structure in which it can be followed. Like even in nuclear industry, we have always followed it, sir. So I will same example of pressure gauge. If it is only for a sump level, I will use a 1,500 rupees pressure gauge. But if it is for a heavy water application, maybe I'll use a 50,000. So I think we all followed in a graded approach at all points. But industry 5.0 per se has got a special flavor. It is personalized. So when I say personalized, you should expect to get a medicine, for example, which is customized to your biological requirements. So which means that tomorrow equipments are being made, which will be called drug dispensers, where capsules are personalized to a patient's requirement. That's an example of personalization. We talk of balancing, self-balancing bicycles. Let us say a person of a particular age would like to drive a bicycle for convenience. It will be an assisted bicycle that is personalized. So you see, personalization is all about, let us say, a chair or a furniture. It is not one common design for geriatrics or one common design for people with knee problem, but everybody can adapt it to suit their own physiological conditions. So that is the fundamental flavor which has come in Industry 5.0, and that goes across the board. It's personalization at all levels. I'm only capitalizing on the point that since personalization is becoming a technology, nuclear industry, which always had a problem of asking for too few components, but with too much of testing, it was always a very high cost to be paid and people are not willing. But now personalization comes as a technique, customization and personalization with codes for nuclear industry. Same technology can be implemented with more ruggedization methods, which I was telling Mehta sir.
Yeah, I think time is also up. May I request Malhotra ji to give a formal?
So, I think all of you friends, all of you will agree that it was a scintillating lecture, I would say. Fantastic. I mean, a little different from the conventional lectures. And in fact, my only addition to it will be that probably he spoke about, you know, if you start from industry 1.0 to 5.0.
You're not audible, sir.
So I think it's, if all of us mute, maybe we'll be better off.
What happened?
No, your voice was cutting.
Yeah.
I will mute all. Just a minute.
Yeah.
Yeah. Yeah, Malhotra ji, yes.
Yeah. So I was telling that the difference. Fantastic. My only comment was that probably when you are speaking of industry 1.0, which was mechanization, if I recollect correctly.
3.0, sir. Anyway, just as matter of terminology.
Okay, okay.
Yeah. Okay, 1.0, industry 1.0. No, I agree
5.0. Yeah. So probably we are covering the last 300, 400, 500 years. But actually the history of civilization is much longer. And even if you look at, I mean, the crux of the issue is that the civilization development is hand in hand with the technology development. And that is why the various civilizations are named after the technology which we have. You know, you have the Stone Age, you have the Copper Age, you have the Iron Age. This only shows that the society, the civilization develops as the technological capabilities of the society develop. So I think it was a fantastic talk. And thank you very much, Kalol, for this.
Thank you, sir.
And of course, after thanking the author, we are very thankful. I'm particularly very thankful to all my colleagues in INS Executive Committee, Mehta Saab, who guides us and encourages us. The chairman of the subcommittee for webinars, Dr. Ramarao, who has been carrying out these webinars more than 2 dozen. I mean, I'll be announcing the 27th webinar in August. So a fantastic job is being done by Dr. Ramarao and his other colleagues in the subcommittee for webinars. I am also thankful to people who are involved in getting the message amongst the masses about these webinars. I am particularly thankful to all the large audiences, the members of INS and other members of the society who are very keenly listening to us. See, we may always see a finite number when we look at the Zoom record, but to that you have to add almost an infinite number. I call it infinite because they will keep on listening to these lectures on the YouTube, so that number is not fixed. I mean, over the years, they will keep listening to these lectures, which are perpetually going to be available on our website on the YouTube. So I anyway thank all the audiences and friends. As has been the practice, I generally announce the next webinar. So our next webinar will be on 20th August, same at 5 o'clock, and it will be delivered by one of the very good friends, Mr. Pradeep Mukherjee, who is the Chief Executive of BRIT, Board of Radiation and Isotope Technology, and who has earlier, before assuming this responsibility, he has worked on very strategic projects also. I think that you will hear when he speaks. Some kind of his CV will be read, so you will come to know what all he has worked on. And his topic is going to be, he is going to speak about the activities of BRIT, about the production and distribution of radioisotopes, radiation sources, and radiation services. So let us look ahead for that lecture on 20th August. Till then, goodbye. I am signing off. So Ramaraoji, back to you.
Thank you. Thank you, sir. Thank you, Kallol Roy.
Thank you so much.
Spending your time.
Bye-bye, Kallol Roy.
And it was a pleasure listening to you after a long time.
Thank you, sir.
Mehta, sir, thank you.
Thank you, Mehta, sir. Thank you very much. Thank you, Ramnamurthy.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you and bye.
Yeah, bye. Bye.